I'm Vint Cerf. I'm Google's chief internet evangelist and the co-inventor of the internet. So let's just explore a little bit what the architecture of the 3D printing ecology might look like. The first thing that we know eventually is we need some standards so that the CAD/CAM systems can drive multiple different 3D printers. Second, we're going to have to come up with a way of describing the things that the 3D printers are making, so I can take a partially made thing from one 3D printer, move it into another one that now knows what it's got, this partially constructed thing, to add more to it. So we have to have this rich ability to tell one printer what it's getting from some other printer. Third, we have to figure out how to agree on standards for moving designs from one printing device to another. We want to make sure that the standards are rich enough that when new printers come along with new capability, the standards allow us to express what it is that we're trying to do. And finally, I think it's going to be very interesting to make parts with the 3D printers, but have robots figure out how to assemble those parts. And so we can see this going step by step by step until finally we have invented an entirely new advanced manufacturing capability different from the one that we use today. No, I don't think that the maker movement or the Fab City idea is in contradiction here. The reason that you want to have standards is that you want to be able to interconnect things at will, even if you didn't know ahead of time that you needed to do that. That's why the internet was designed to connect anything to anything else, because we didn't know what needed to talk to what else. So I don't think that we're changing the ambitions that the Fab City has. In fact, if anything, this is a little bit like the chip fabrication world, where you wanted to do design which was independent of the details of the actual chip fabrication technology. And in order to do that, we had to create an abstraction for very large-scale integrated circuits that didn't rely on the specific physics of the fabrication system. Once we did that, the same VLSI designs could be made by different chip makers, and now you could compete to see which chip maker could make them faster or cheaper or, less expensive. So we have lots of opportunities here because we're still at the early stages of the 3D printing ecology. Hardware fails all the time, and so you almost can't escape it. Software does too. I don't see those as particularly different. Hardware is just software in a different form for all practical purposes. The 3D printing community is going to have to recognize that it can't be simply competitive. That in order for people to make use of this technology and make an infrastructure of it so new businesses can be built on top, there's going to have to be commonality, there has to be cooperation, there has to be willingness to share ideas. In the absence of that, you are presuming that your company knows more than any other company does about how to do this, and you would probably be wrong. Well, since I've only been here for about an hour, I don't have a very good sense of what's been going on for the last few days, except that the level of enthusiasm is very high. And the idea of mixing people together who are making the equipment and who are using the equipment is really important, because that's where the feedback loop comes. The idea here is to discover which competitors are making things that the users really like a lot. If you don't know that, you're going to have trouble figuring out what is your market. But this idea of getting people to do things that cause their systems to interwork. If you didn't have a CAD/CAM studio here, next year, a CAD/CAM studio should be in place so that the makers can sit down and design things, try printing them on different printers in order to see what happens. And so this experimental environment can be a rich way of discovering new ideas and things that work and things that don't.